Hello and welcome to 11-5 volume of prisms and cylinders from the Big Ideas book. So the idea in talking about volume is the number of non-overlapping unit cubes that will exactly fill the interior. So in Cavalieri's principle, it says that if two three-dimensional figures have the same height and the same cross-sectional area, then they will have the same volume. So this has to do with those oblique figures that we were talking about. So I think it's pretty much related here if you look at this stack of discs, and if you look at the discs pushed over so that they're oblique, every cross section, so every single disc still has the same amount of volume, whether they're sitting square up or whether they're pushed at an angle. So no matter if they are square, meaning that there is a right angle here, or whether they are coming down and they're oblique, the formula for the volume is going to be the same. So we basically have one formula here, and what it is the volume equals the base, area of the base. When it says a capital B like that, what that capital B means is the area of base figure. Okay, so sometimes that figure could be a triangle, sometimes it's a trapezoid, sometimes it's a rectangle, but that's why we use the general capital B, and then we fill that B in with whatever figure it is. Now, really, we can use this same exact formula for a prism and a cylinder. We just change this B. This B, if we jump to a cylinder, is just going to always be pi r squared, because no matter what cylinder you have, it's always going to be a circle on the top. So really, you only need to know this one formula, capital B times h, but a lot of times people just write the cylinder being pi r squared times the height. So what is the volume of the pizza of a thickness A and the radius of Z? So we are using volume is going to be your pi r squared times the height. So we've got pi, radius squared. So what do they say? The radius squared is z squared. My 'T's and z's look alike. And a thickness of A. So it looks like we have pi z A. Pi z A. All right, getting on to the real math of stuff, finding the volume here. So volume is going to be pi r squared h. So we have pi radius squared, so we have 3 squared times the height is 5. So that's 9 times 5, so we have 45 pi. If they want this in exact answers with your label of feet cubed. And if we round it to the 100th, it's 141.37 feet cubed. So we have the exact answer, 45 pi, and the 141.37. All right, finding the composite volume here. So I'm going to take the volume of the box, and I'm going to add to it the volume of the cylinder. So the box is length times width times height, and the cylinder is going to be pi r squared h. So it looks like we have 10 times 5 times 3. My brain and we're not working together here. 10 times 3 times 5 plus pi, my radius is 2 squared, times the height, which is 4. So it looks like here we have 150 plus 2 squared is 4, 4 times 4 is 16 pi. So here's an exact answer of meters cubed, and then rounded to the 100, it's 200.27 meters cubed. All right, next volume here. So it looks like we're building a rectangular chest, and we want the length to be 6 feet, width to be 4 feet, and the volume to be 72 cubic feet. So what should the height be? Well, the volume is going to be length times width times height. So we already know that volume 72, and they say the length is 6, the width is 4, and they want us to find the height. So basically we're going to take 72 and we're going to divide by 24. So it looks like we are going to get 3 feet for the height. So that's just using the formula backwards. And lastly, here's a situation that we have talked about numerous times. And we've talked about if we have the volume of this, and now each dimension is multiplied by 3, how does multiplying by 3 each side affect the volume? So we've talked about it from one dimension, meaning if we're talking about perimeter and every length is doubled, how does that affect the perimeter? So if the length's doubled, how does it affect the perimeter? And we say that that's a 1-to-1 ratio. So we were saying that the perimeter would also be doubled. And then we go on and we've talked about the area. So if we double each side, does that mean that the area is doubled? And now if we triple each side, does that mean that the volume is tripled? And some of you are saying yes, and some of you are shaking your head no. So we're just going to do a little experiment here, and I'm just going to pick the sides to be 2, 3, and 4. So the volume of this original figure, if all the sides are 2, 3, and 4, we are going to get 24 units cubed. Now, some people think that we're just going to times by 3, and that the new volume would be 24 times 3, and 24 times 3 is going to get us to 72. So that's what some people are going to think right away. So let's just try a little experiment and see what happens when you multiply each side by 3. So 2 times 3 is going to make this 6. 3 times 3 is going to make this side 9, and 12 times 3 is going to make this side 12. So the volume of the new, when we multiply by 3, that volume is going to be 6 times 9 times 12, and that new volume is going to be 648 units cubed. So if you took 24 times 3 and got 72, is that what truly the new volume is? And the answer is no. So it is not just multiplied by 3. So what do? We'll take that 648 and divide by 24. And I think you're going to get the number 27. So how does we get 27 when we start with a 3? Now remember what our label's here. It is units cubed. So if we take this scale factor and cube it, that is the dimensional change. So when you take 3 cubed, that is where that 27 or 27 times the original. So if we would just take that original 24 times 27, the new volume would be 648. So we don't necessarily need to know the dimensions, we just need to know the scale factor. Okay, now how does this work if we multiply by 1/4? Well, again, you can go in and take 1/4 of everything and get a new dimension here. So I did that. So if we do that, 1/4 of 2 is 0.5, 1/4 of 3 is 0.75, and 1/4 of 4 is 1. Or we can just go back to this original number, 24, and we can multiply it by this scale factor cubed, which means we're really taking 24 times 1/64. And if we do that, I think we get our new volume to be 0.375 units cubed. So remember, all we're going to do is take that scale factor and cube it for volume. Okay, so whether in the original one it was 3 cubed, or whether in the second one it was 1/4 cubed. And remember, if we talk about area, it's just taking area and squaring it, because think of that label on area. We would take 3 squared, and it would affect the area by 9 times. All right, good luck on your homework.